It turns out that derivatives also help us find the slope of a tangent line. A tangent line to the function f of x at the point x equals a is a line that just touches the graph of the function at the point in question and is, quote, parallel in some way to the graph at that point. Take a look at the graph below. Here, this is an example of a tangent line, and here, this is an example of not a tangent line. At this second location, the tangent line would look something like that, and it would just touch right there, and the tangent line would look something like that. So let's use that information for example 6, where it asks us to find the slope of the tangent line to f of x equals x squared at x equals 2. So let's quickly sketch x squared. So we know it's a parabola, and it looks something like that. And let's say x2 is here. And so our tangent line would look something like that. So at the very minimum, I may not have sketched my graph in the best way, but at the very minimum, we should be able to recognize that the slope of the tangent line is positive. It's negative at places like right here. Maybe if I looked at like -2, that would be like right here. And if I drew the tangent line would look something like that. And that slope is negative. But when x equals +2, we can see here that the slope of the tangent line is positive. So if we're doing our algebra and our calculus when we're calculating the derivative, if we find that the slope of the tangent line is not a positive number, then we probably did something wrong. So the first thing that we want to do is we want to find the derivative function. So we want to find f prime of x. And the way that we're going to do that is by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. And so I'm going to come down here and say f of x plus h is x plus h squared. And we have expanded this multiple times now. Hopefully you're getting sick of it and you recognize, maybe you have it down like the back of your hand and you say that that's equal to x squared plus 2xh plus h squared. And so this equals the limit as h approaches 0 of x squared plus 2xh plus h squared minus the original function f of x, which is just x squared all over h. Now remember that hint that I gave you. Whenever you're calculating a derivative like this, you always want the h in the bottom to cancel out. So that means that in the numerator, when you're doing your algebra, everything that does not have an h in it should disappear. And if it doesn't, then we probably did something wrong. But that's the case here. So we have the limit as h goes to 0 of 2, I'm going to factor out the h, of 2x plus h all over h. And so this and this will cancel out. So we have the limit as h goes to 0 of 2x plus h. And we can just plug in or substitute h equals 0 to get 2x plus 0, which is just equal to 2x. So our derivative function, f prime of x, is equal to 2x. Now you might be wondering, how does that give us the slope of the tangent line? Well, it turns out that if you take the x value that you are wondering about, you can just plug that in to the derivative function, and that will tell you the slope of the tangent line. So f prime of 2 is equal to 2 times 2, which equals 4. And 4 is a positive number. And it is the slope of the tangent line at x equals 2. And remember, from our drawing up above, we said that it should be positive. So this is our final answer, 4. I just wanted to quickly illustrate for you what is happening when we're calculating the derivative of the f of x equals x squared function that we just did earlier. So here is f of 2 plus h minus f of 2 over h, and it says that m is equal to 7 here. That means that when our h value is 3, we're looking at the point 2, and 2 plus 3, which is giving us 5. So basically, we have a secant line here. The green graph is our f of x equals x squared function, and the red line is our secant line. And this thing here, m, is calculating the slope of that line, which in this case is 7. But as h gets smaller, as h gets closer and closer to 2, notice that our slope is decreasing. And what is it going towards? What is that number going towards? So as my h value gets really close to 0, like we're taking the limit as h approaches 0, what is happening to the slope of our secant line here? Well, when it gets really close to 0, let me plug in a number like 0.0001. Look, it kind of looks like a tangent line because it's really close, and basically here our slope is very, very close to 4, which is what we calculated previously. So that's what's happening. This is kind of cool that we can view our secant line kind of morph into a tangent line. So watch it come back. As it gets closer and closer to 0, it gets very close and approaches and almost becomes a tangent line. And when h is 0, if I plugged in 0 here, it would be undefined since, h is in the denominator here, so that would be undefined. But if I made h something really, really small, it's very, very close to 4. So that's what's happening with our derivative function. It's helping us calculate the slope of this secant line, but when h gets really close to 0, it's basically calculating the slope of the tangent line for us.